All right, so we're at the website and we want to see how to print and assemble each piece of this kit. So we've got the spaceship, which is the SpaceX upper stage. We got the booster, got the orbital launch mount, which is down here, and we have the orbital launch integration tower. So if you go to each one of those, you can go to this page. I'll put links to these in the show notes. So it's got a video about how to print it, um, but I'm going to be using the instructions here. So you start with step one. It talks about the main parts. These steps that are listed here are folders you get with STL files in it. So we're going to examine those as we go along. It tells you how to put each part of it together. And so again, I'll put links to this, and I'll just be going through this as I go. And then the one for the booster is the same. It's got this doesn't have a video. It's only the Starship that has the video, but it has the instructions. So we can go to the instructions. Just expands it. Let's see. Where is it? Here. Okay. All right. So here's the print and assemble instructions. Again, it's got step 0, step 1, and so on and so forth. So, and then the orbital launch integration tower again has the different steps. And then the last one is the orbital launch mount. The video doesn't seem to be working here, but so as we go through and print everything, we go into these different steps. Looking at the web page, I use an iPad next to my workbench, and then I just look at the web page about different steps, and then we're working to integrate the different parts into groupings of parts to print at the same time based on their color. I'll go through that. Then we can also use this as a guide. So. All right, so the Starship is printed in, and the tower are printed in 3 parts. The booster too. There's silver, which is supposed to be stainless steel, so we're going to use our shiny silver. And the tower, or the tower, the tower might have printed in gray to give it a little bit of contrast. And then some parts are black, like the base and some other things. So usually we always print the shiny silver first when we're printing things like, unless we have white, which don't have white in this project. So we're going to start by gathering all these silver parts from the download. So what happens is when you buy the STLs, it downloads all the STL files. So we're going to start with Spaceship. That has most of the silver on it. So step 0, I'll just bring this in. It's going to be too big, but it isn't too big. Okay, so this shows that the final assembly, when you print all the parts, you can put it together like this. So this is the test launch tower. So you can show how they test the rockets before they stack them. So the Starship is tested on this thing, and then the booster is usually tested on the orbital launch mount. Anyway, so we're not going to print it like this because it has to be different colors. So we remove that. Then we go to step 1. So step 1 is all the silver parts of the body. So we'll get all those in. There's all the silver parts. And then we're going to add, on the flaps, there's, that's step, step 2 is the heat shield for the body. Step 3 are the flaps. So we want the front flaps, front part of each flap. That's printed in silver. So we want to print all these 6 things together as a group. If I just say center and arrange, it's going to mix them up. So we're going to grab this. We're going to grab these and move them out of the way a little bit. Yeah, we'll just move them up this way. Let's see. I think we go. This is positive. Yeah. Let's move up there for a second, and then we'll take the other ones and move them toward the front. So it's better to print things that have about the same height together, and then print things that are a similar height together as well. So these ones we want to move so that they're not underneath these, obviously. So let's move these in the negative direction. Everything's basically centered. It's going to put the taller parts to the back and these short parts to the front. Okay, so let's save that. Now let's look at our profile. So this is I'm printing it in PLA. I thought about printing in PETG, but PLA will print faster, and I have other products that are PLA that I hold, like my Mars sample tube, and that seems to be fine. So also, I didn't have a shiny silver PETG, so rather than buy that and test that out, I'd rather use the filaments I already know. So this is our standard PLA profile. We use a 0.9 multiplier, 0.3 nozzle diameter. We use automatic that uses a 0.48 extrusion, which speeds up printing a little bit. We use 2mm layers, outer perimeters 2, solid layers 3, and then we're going to use support because one of these things needs support. So infill, we'll just use a standard infill, 50%, which I like to use, makes it stronger. And support, okay. And then temperature. Okay, so temperature 225 is what I use for the nozzle on the Guider 2. That's one reason I think it's a little bit higher than other people might say is because I'm using the Micro Swiss nickel-plated nozzles. You need a little bit higher temperature with those. And then the bed temperature is 50. I've had a lot of good success with that. And the cooling, 0 on the first layer and 100% the rest of the way. Speeds, this is the default speed the Simplified 3D picked for PLA a long time ago, and I've had good luck with that. And a travel speed of 4800. And the rest of this stuff is pretty standard. Just use the defaults. So one of these objects needs support, so let's go ahead and show that. So a little over 10 hours to print. So this one needs support. This is where the rockets go into the bottom. So we're going to try automatically generating supports and see how that works. And overhang angle, we're going to use, I'm going to put in 90. I never tried 90 before. Let's see what it does with 90. Alright, didn't generate any support. So let's try, I usually use 88 here for some reason. There, okay, so it generates supports. So don't use 90, use a little bit less than 90. Alright, so generating supports for this, that looks like a pretty good spread there. I can live with that, so let's try to print that again. Yeah, so let's have to remove supports from this area. Now the supports are at this angle and the bridging is at this angle. So we want to change the bridging angle so that it goes perpendicular to the support. So let's go back and fix that. Let's see, bridging angle. Where's that? Other. Alright, so to get the supports to line up with the bridging angle, I left the bridging angle alone at 0. I'm just going to leave that checked though. And the support, you say support panel rotation 90 degrees. The default is 0. So if you put 0 in it, it uses the hatching pattern, which is a 45-degree hatching pattern. So put this in as 90, and then when you print, so the supports go this way and the bridging goes this way. That's what you want, it's the shortest distance. So, and then see the hatching, the cross hatching for the infill is going at a 45. So okay. All right. Well, that was more complicated than it needs to be. This doesn't need any support because it's too small. Alright, so it's over 70 degrees in the garage here, so I print with the top, with PLA I print with the top off. If it's over 60 degrees, and over 70 degrees I also print with the door open. If it's over 80 degrees, I put my fan on and blow some extra air in there. Anyway, the first few layers have gone down, looks great. Those are the sections of the Starship, and these are the flaps in the front here. And here you can see the nose cone section that needs, or actually the engine section, that's the bottom section, that needs the supports. So you can see the supports are printed there. And that all looks perfect, so. Looking good. See you in about 10 hours. Alright, it's done, finally. Let's see how long it took. It took 11 hours and 23 minutes. The prediction by Simplified 3D version 5 was 10 hours and 26 minutes, so almost an hour slower. That's typical. So we're going to put the reheat back on so things don't cool down. Let's take this out and we'll take it over to the workbench and see how, look at the parts more closely. Alright, so just off the first impression, everything looks great. So let's flex this and get these off. So the PI surface, they come right off. These will have to flex some more, but let's look at these. So these are the individual pieces for the sections of the Starship. So each one is different, so we should be able to tell which one is which. Here's the nose cone. So remember that overhang here. There was no problem with that overhang with no supports. And it printed this little square up at the top to attach the nose cone. So the only question is, how did the supports come out? So here's the supports for the engine section. So usually I use these little pliers to pull these supports out. So they come out real clean, and look at that bottom, perfectly flat. So supports work great. Let's put these aside. And this didn't require support, like I said, so everything looks super clean. Let's flex this some more and see if we can get these pieces off. So these are the flaps. That flap is not quite off. So I need to use my little. So for the PI surface, I use this blunt spatula so I don't scratch it. So sorry about that. These are the forward flaps, I think. And then the rear flaps are bigger. Alright, so everything came out great, and it's on to the next color, which I think is going to be black. Okay, so now we're ready to do the black part, so let's import those. So step 2 has most of the black parts, so we're going to grab all those. So these are all the heat tile sides of the Starship, and it's also, there's the nose cone, and then it's also got an assembly tool that helps you assemble the nose cone onto the rest of the ship. So that's what this is for. You put this upside down here, I think. I'm going to watch the video and I'll show you how I do it once I get it set up. But these don't need any supports. There's a little bit of a overhang here, a little small section, but as we can see, that's not going to require supports because it's too short. So should be able to print this if your printer is tuned correctly with the cooling. That's a very short distance, so that bridging should work. If it's a little bit raggedy, it's not going to matter. That's where the flaps go. So the flaps are held in by magnets. I'll show that later, but so that's that. If there's a little bit of a raggedy surface here on the bottom side of this bridge, it's going to get covered up by the flaps, so it's not a big deal. Alright, so that's not all the parts though. We need to get the, speaking of the flaps, we need to get the flaps, so let's import those. The flaps are in step 3. In the silver parts, we printed the front of the flaps. Those are in silver. The back, or the unlabeled side, is the side with the tiles on it. So this is the tile side. So we're going to rearrange these. Okay, so I found if you have something like this and something like this, you want to print those together. So I'm going to move that over there. So putting stuff in the center of the print surface is usually better. It'll be more level rather than other places. So, all right. So as far as the parameters go, I'm going to use the same parameters as we did before for the silver. Everything is the same. So go back and look at that part if you want. But I just changed the label here. So prepare to print, and it's thinking in about 8 hours and 10 minutes and about 72 grams of material. So, all right, so that looks pretty good. Well, I wanted to show you how great this this section stuck to the PEI, but unfortunately I jostled it as I put it down. So this is the trickiest part of the print. It's a very small area attached to the surface, and it's off center, so you have to have good bed adhesion or it's not going to work. You could put a brim or a raft on this. Probably be a smart idea. In this case, I was confident in the PEI surface and this filament, so I didn't do that. But you can see how easily it came off. So just barely touching it, it comes off of the PEI surface, which is what makes it so great. Anyway, these all look like they came out great. There's lots of good detail on the hexagons, heat tiles. Of course, here's the stuff we printed already. So we'll be assembling these together. We need to get the magnets, which I haven't got yet. Should be showing up pretty soon. And we can put all this together. And we still have to print the hidden parts, so I'll go over that next. Now this is the nose cone. It's a little bit stubborn. Let's see if we can get it to come off. There it goes. Okay. All right, we have one last filament to print for the Starship. And in this case, I'm going to be using black, but I have a cheaper black filament. That prints pretty well. It doesn't print as well as the Fila Cube. So because of all this detail on these hexagon tiles, I want to use my best filament for that because I want it to look good. But I have this JO, which I've reviewed on the channel. That's about $5 cheaper a kilogram, something like that, maybe even a little bit more than that. So we're going to start with black. We're going to remove all these, and we're going to import the hidden features. So let's see. Is it no? Inner compartment. So it says you can use a 0.3 tolerance. That makes this slightly bigger than the other one. If you have a well-tuned pre-printer. So I think my printer is pretty well-tuned. This is the spline that goes down the middle of the Starship to keep it from flopping around. So even though we're going to glue it, I think helpful to have this in here. I'll glue this in too, just to make it stronger. It's going to be handled a lot. So I'm going to print this, and then let's take a quick look. Let's go ahead and save this. Take a quick look at the silver project again. So these are the parts we need to glue together. These sections here. There's 6 sections, and in the video, assembly video, which I have a link to in the show notes, he uses magnets in each section, which I think is a waste of money. So he also provides connecting rods. I forget what he calls them exactly, but they're like little splines in between each section. So instead of a magnet in these 3 positions, and over here 3 more magnets, you can put little connector things in here. So now we are going to be putting magnets on these guys because we want to connect this section to the booster, so it can be picked up as one thing. But in between these other sections, we only need splines. So this is the bottom section. That's where the engines are. So then between here and the next section, we need 3 splines. And between this section and the next section, we need 3. And or actually, yeah. So this goes to this. That's 3. This goes to this. That's 3. That's 6. This goes to this. That's 9. This goes to this. That's 12. And this goes to this. That's 15. So we need 15 splines to connect all these sections. Yeah, because we don't need 18 because with these 3 we aren't using it for these 3. So let's go back to the hidden one. I'm going to import optional parts. So it calls it a location pin. Okay, that's fine. That's over to the side so we can't see it. So we said we needed 15 of these. So these are just little simple cylinders with cones on them, and they fit in between those 2 sections to glue together. So I don't see any reason to have those little short sections because I'm going to be transporting in a box that's at least 18 inches long. So the booster and the Starship will fit as all glued together. The tower is going to be too tall, so I have to print that in 2 sections, but we'll go over that later. Alright, so here's the location. We need 15 of those, so we'll duplicate. So Well, it says 15 there. All right, so we want these all to print together. Save that and see how long that takes to print. So again, we're using the same parameters for printing this. We're just printing in a different filament than the other ones. That's cheaper than everything else because it's going to be glued. You never see it after it's assembled. So this is going to take 3 hours and 54 minutes. So you made a nice spline here because it's empty inside. So there's no reason to fill this because it's just acting as a thing to keep things from jostling around. So, all right, well, this is another small surface area print. Very tall. That's tricky. But the PEI came through again, so you can see this is a pretty small area. So again, you could print a raft. If I was worried about it tipping over, I'd print a raft. But with PEI, I don't really have any problems. These are little locator pins. They all came off right away. And they all look pretty good. Little cylinders with pointy, semi-pointy ends. So those should fit in here. Yeah, so that fits in there nicely with a little bit of slack. And then once we glue it, it should be fine. Let's see how this fits in here. Yeah, so that's a nice tight fit. So our 0.3 millimeter tolerance worked well for my printer. It said for a well-tuned printer, so mine's well-tuned. I use it every day, so it's pretty well-tuned. Yeah, so we have to make sure we line these up the right way, obviously. So that'll take some doing. But anyway, so everything looks like a good fit, good print. So Kex came through. We'll be using this for the hidden parts on the booster as well. If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.